Welcome back. This is Module 1, the framework for Introduction to Transportation Planning, developed by Professor Mohan Venagala. All materials are copyrighted. We are now starting Part 1C, a systems approach to transportation planning, which provides a structured way to view the complex interactions within the transport system. To recap, Part 1A covered population demographics. Part 1B reviewed the planning process framework. This section, Part 1C, will now outline a structured systems approach to transportation planning. The transportation system can be broken down into 5 basic, interconnected elements: infrastructure, rolling stock, terminals, management, and most critically, people. The system is dynamic, functioning as an ecosystem where 3 forces constantly interact: supply, demand, and control. The physical elements of the system include infrastructure, vehicles, power systems, fuel sources, and the control and communication systems that govern movement. Infrastructure is comprised of guideways, which are the fixed routes like highways, and terminals or nodes, which are points where movement starts, ends, or transfers, such as airports and bus stations. Planning involves considering both internal factors, which are controllable elements, and external factors, such as government regulation, competition, the needs of the people, and available resources. Rolling stock, the movable component of the system, includes private autos, public transit vehicles, rail cars, and dedicated freight vehicles. Power systems are rapidly evolving, transitioning from traditional IC engines to hybrid, electric, and potentially fuel cell technology alongside non-motorized human power. Energy sources are categorized into traditional fossil fuels, renewables like solar and wind via the electric grid, and alternatives such as hydrogen and biofuels. System control involves both human elements, such as drivers and controllers, and the technology element, including traffic signals, sensors, and GPS-based intelligent transportation systems, or ITS. Understanding the customer is complex. Travel choices are governed by income, purpose, temporal and spatial factors, and their perception of safety. Key policy considerations today include sustainability to reduce fossil fuel dependency, implementing transit-first policies to boost ridership, and improving walkability for accessible communities. Planners face trade-offs, such as balancing high level of service against high cost, choosing network designs, and selecting strategies like demand management versus capacity building. External factors are pressures from outside the system that shape its structure. These include government, competition between transport modes, financial markets, and energy cost. The government's role rests on 3 pillars: regulation, funding for infrastructure and maintenance, and determining user fees like tolls and taxes. Competition is inherent in transportation, existing between different modes and between carriers within the same mode. This impacts pricing and service quality. Guideways are fixed physical assets. This involves securing the right-of-way, adhering to design standards, overseeing construction, and ensuring ongoing maintenance. In an urban context, the system is shaped by demand variables, influenced by land use, and supply variables, which include networks, terminals, and on-demand services. Mobility, the ability to move quickly over long distances, is inversely related to access, the ability to reach many locations. Freeways prioritize high mobility, while local streets maximize access. Transportation modes exist on a hierarchy defined by this trade-off. For instance, air travel offers high speed but low access, while walking offers maximum access but low speed. This figure illustrates the accessibility and speed of different transportation modes. The figure doesn't show ride-sharing services such as Uber and Lyft, but it is essentially dial-a-ride service. System capacity dictates how many people or goods can be moved, ranging from high-capacity freeway systems to different forms of rail. What is the difference between heavy rail and light rail? System performance is measured across several dimensions, including volume like vehicle miles traveled, coverage of the region served, and the vital metric of safety. Level of service, or LOS, is the overall user experience. It includes in-vehicle travel time, access and wait time, out-of-pocket cost, and the comfort of the journey. Transportation systems have wide-ranging impacts, fundamentally shaping the environment, the economy, cultural activity, and the pattern of land use development. The system operates as a continuous cybernetic loop where supply affects demand, which in turn influences land use, and this land use change ultimately creates new demand. This cycle illustrates how road improvements can be self-defeating. Increased accessibility raises land value, changes land use, increases traffic, and necessitates new improvements. That wraps up Part 1C on the system's approach to transportation planning. Next, we will discuss an overview of the travel demand modeling and forecasting processes in Part 1D.